Assalamualaikum and good evening. My name is Muhammad Wajibata bin Mustafa. Today I'm going to present about introduction for our topic, that is full scope modulation, or the short form is PCM. Right, PCM is a method used to digitally represent sample analog signal. It is the standard form of digital audio in computers, compact discs, digital telephony, and other digital audio applications. In a PCM strip, the amplitude of the analog signal is sampled regularly at uniform interval, and each sample is quantized to the nearest value within a range of inputs. Okay, after that we go to the next slide. That is one of the example of a diagram for full scope modulation of PCM. Right, before the input go to sampler, it is continuous time, continuous amplitude analog signal, and the input will go to the PAM sampler. PAM sampler will produce discrete time continuous amplitude signal of PAM. Then the PAM input will go to the quantizer. The quantizer will produce PCM input. After that, the PCM input will go to the encoder, and the encoder will process the data and will produce interbit stream out signal. Right, and now we gonna see another example of the diagram. In this diagram, you can see it's more clearer than the other block diagram that I show you just now. And in the block diagram, in the PCM encoder, there will be three processes. That is sampling, quantizing, encoding. Okay, before the input go to sampling, the input is called analog signal or analog signal lah. And then after go through the sampling process will produce a PAM signal that come in this state. Right? After that, the PAM signal will go to quantizing process, and the quantizing will produce a quantized signal that will come in this state. Okay, and then the quantized signal will go to the encoding process, and the encoding process will produce return it to data. This is the, as we can see, short explanation for dot diagram. Right, that's all for me. I'm going to pass to my group mate. Thank you.
Assalamualaikum and good evening. My name is Arshad bin Mustafa, and I would talk about the modulation of technique. PCM consists of three steps: sampling, quantizing, and encoding. PCM may sound very complicated because it involves many big words, but it's actually a very simple process. Sampling. As you can see, analog signal is continuous over time. It looks like the picture. If we draw a graph, represent an analog signal wave. Sampling is a process of finding the number of samples so that original signal can be represented by those samples completely, and it should be possible to reconstruct the original signal. The red continuous line is original analog signal. These vertical blue lines are samples. It is basically discrete value of amplitude with a regular interval over time. That's why I call PAM, pulse amplitude modulation, in the process of sampling. Palm signal is simplified the result of the series of these discrete samples value. The number of samples per second is called sample rates. As you can see at picture, sample rates is called how many pure virtual line in palm signal. To measure sample rate, we use hertz. Example, 1 sample per second is 1 hertz. Quantizing process is the process of rounding off the amplitude of laptop samples to a manageable number of levels. This example that we encode the sample with 8-bit depth, we can see it will match decimal number 255 equal to the binary number of 1111111. The sample at the very bottom will be aligned with the decimal value 0 to the binary number 0000000. And that's all for me, and thank you, and I would pass to my friend is Muhammad Hazri.
Assalamualaikum, I'm Hazri. Okay, now I was going to continue about how the simulation works. Before that, I want to explain about exponential growth. You can see that the things go pretty fast in any exponential cycle. 16 bits can represent 65,000 different values. 24 bits represent about 16.7 million values. 32 bits can represent a whopping about 4.2 billion state values. That is the power of permutation and combination I want to send for you. And this is the number of bits represent of the exponential. So we can say that sampling is a capturing an amplitude value. This value is captured in the process called quantization, as well as with the time activity system have a certain resolution on the amplitude. The higher the resolution is, the more accurate the digital representation of the waveform can be. This is determined by the bit depth of the recording. The higher the bit depth, the more dynamic range can be captured. So, 24-bit system has higher resolution than 16-bit recording at the theoretical dynamic range of 16 dB, while 24-bit audio theoretical dynamic range about 114 dB. You can imagine that mixing with audio that has a 24-bit resolution much easier and more efficient mix compared to 16-bit, since you literally have more value on amplitude. Now, the system has two basic properties that define the train by the original analog analysis: the sampling rate and the bit depth. For the PCM module is sine wave the factor 1, the sample and type for PCM. The quantized value and sampling moment are 8, 9, 11, 13, 14, 15 directly, and turn back to 14, and then follow the sine wave response. And encoding this value as binary number will result in the following settings: which is 1, 0, 0, 0, and then bit number which is 2, 3 of 3, and 2, which is get an 8, and then ada number for the 8 number. And we for the 9, 11 is 1001 and 1011, and the continuous number is follow as decoding from the sine wave equated that we had sample and quantized. The sine wave is sampled at a regular interval shown as figure. Some concepts important for coding implementation. Two parameters that determine the quantization is a partition and a group. Quantization partition defines several contingents from overlapping range of the value within the set of real numbers. The partition separates the real number into the four sets. First, the samples are not more than 0. 0 for the sample rate are not more than 1, and 1 the sample rate not more than 3, and 3 are figures for the sample rate. For example, the vector group is determined and of -1, 0, 4, 5, 2, and 3. It's one possible group for the partition. Okay, now I want to jump to the simulation. Now, this is a coding simulation that is done in our segment. First, we set an interval like this. Now, we create a C input part, which is a quantized partition define set of real numbers. And we call partition and now we create we set a cost time and subplot and then we create a AC signal, quantized signal, and PCM plot. Okay, I want to run the coding, which is we enter the bit depth of this encoding like 2 bit, 8 bit, 16 bit, and 32 bit. Now I want to show about the 2 bit how the output is outcome. Okay, you can see the signal that we received and has been quantized signal, and this is how the encoding had come. Is with 2 bit is 2 and 2, which is that have we done. Okay, now I want to set for the 4 bit and 8 bit. Okay. Now the encoding got a smooth result as well as the output bit higher, get higher or increase. Now I want to, for the 16 bit, it's more smooth than 8 bit, and now for the 32 bit I want to show. Yeah. Okay, we can show that for the message signal we receive magnetized, and the more the high bit, the more the smooth frequency, the more the waveform that create for the encoding signal. Okay, that's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Alright, I will continue for my part of summary. Okay, in summary, sampling convert a time varying signal into a discrete time signal, a sequence of real numbers. Sampling is like drawing vertical lines with a regular interval. Quantizing process is like drawing horizontal lines, and each line has a specific measurable bit value, and make each sample flat top mesh a specific horizontal line. This way, each sample can be uniformly encoded with specific bit value. For conclusion, we'll be able to understand one of digital modulation technique, as we can generate the required pulse code modulation PCM signal. Then we understand how to plot the pulse code modulation PCM signal. That's all for us. Thank you very much.